All right, good morning, everyone. As Alistair said, my name is Marc Jones, and I'm the VP of Product Innovation at SoftLayer. And SoftLayer is an on-demand cloud computing infrastructure as a service platform. And as many of you probably know, we were acquired this summer by IBM. And it's actually a very exciting time for us, not just from the general cloud technology landscape, but also within SoftLayer, thinking about everything that IBM is going to bring to SoftLayer and everything that SoftLayer can bring to IBM. So today we're going to talk a little bit about performance in cloud architectures and being able to select the right architecture to fit your computing needs, your project needs, kind of picking up a little bit where Alistair left off. So when we look at the marketplace today, particularly from a cloud standpoint, obviously I am deeply embedded in the cloud. My team is focused on R&D, new product innovation, and really trying to figure out kind of what's next in the cloud, and really learning what customers are doing, what they're wanting to do, and then helping them to get there. So when we look at some of the key verticals that we see embracing cloud today, and it's an interesting space because it's not just the verticals like take big data and analytics. There's a lot of companies today that are producing the products and services to power big data. But when I took a look at our customer base and I went through and kind of dug into our top, say 25, top 50 customers, it was interesting to me that a lot of them are not in the big data space, but every single one of them is using big data today. And so it's really becoming a powerful aspect of cloud, being able to leverage everything that it offers for big data. And then from a mobile standpoint, we're seeing tremendous growth on the mobile platforms and leveraging cloud to not only enable kind of the server-side operations, but to be able to gather, collect, analyze more data. And then social media and the variety of offshoots there, really taking advantage of the power of cloud. And what's interesting about all these industries, all these verticals, is that they all were early adopters of cloud. And they're not just embracing cloud, but they're actually pushing cloud forward very fast. So when we think about kind of that enterprise transition, when they're moving from in-house, on-prem to the cloud, starting point, this is probably a little bit older, but just call it traditional OLTP. But really that in-house, you own the app stack, you own the gear, and you want to now take that step from in-house and start leveraging the cloud. One of the things that we've seen when we talk with our customers is the way that the enterprise kind of views IT versus the way we like to call it internet scale, but the internet-based applications and companies view the internet and cloud. So from an enterprise standpoint, a lot of times IT is a cost center. And it's really about minimizing cost to try to maximize value for the enterprise. You know who your users are. You typically know when they use your services and how they use it. So it's pretty easy and predictable to build out an infrastructure, to know how to scale that infrastructure over the long term. And then you contrast that with internet scale applications where you don't know who your customers are necessarily. You don't know when they're going to visit your site. You don't know how many are going to visit your site. And if for any reason you go viral, you may have a rush of traffic, and that has tremendous impact to your infrastructure. So from a performance perspective, a lot of times we hear a lot about compute and really just thinking about raw horsepower of whether it's the VMs that you're getting, the servers that you're getting, and how fast are they. But as we work with these companies that are really embracing cloud, and particularly the ones that are focused on scale and performance, a lot of times it comes down to latency and throughput, in addition to kind of the raw compute power. So when we talk about latency, it's really a measure of time delay, right? How quickly does a packet traverse the network? How quickly does a response come back to me when I make an API call? Or how quickly does a web page load when I pull it up in my browser? And then throughput really is that measure of data transfer. And how quickly can I get data from the source to that destination, or typically that's going to be on disk somewhere, whether it's in a database or just raw to disk. And what we've seen is the companies that really focus on performance, that really care about performance, they really end up focused on latency and throughput, and really kind of the combination of the two. So starting off really with the API web and metrics. If you think about just a website or an API, obviously a ton of content, and almost all the interactions tend to be with a person. So that latency, that expectations of how quickly a web page is going to load is, a second, 2 seconds. Most people are going to be happy. You start getting beyond that, and people get a little frustrated these days. So there's one aspect of being able to serve the content and how quickly you can get that content to the end user. And then if you start talking about metrics that are created and derived from those interactions that occur with the API or the web, that's about getting data from the source to disk. And that could be log data. That log data may be going to disk. That log data may be going to New Relic, maybe going to Google Analytics. So that's about how much data I can get from that source to that destination. And then ultimately, what am I going to do with that data? How quickly can I process that data? And what are the demands on that? And typically, when you're looking at kind of the API web use case, it doesn't have to necessarily be super high performance. Now, we're definitely seeing a trend of people moving to that near real-time notion, but it's not, time is not of the essence in a lot of cases with our customers. When we look at gaming, and this really can kind of fit any of the mobile applications, gaming is a space that's incredibly demanding right now. And it's really that evolution of gaming where they've gone from just playing a game on your handheld where you download it, you play it, to a lot of games are always connected. When you play it, you have to be connected. And they're gathering so many data points to help them really evolve their games. And a lot of times, they want engagement. They want to be able to monetize that engagement. And they do that now through data. And so they're really pushing, I think, the industry in terms of like adaptive algorithms, where they get the data and they do a ton of analysis on that data. So what we see is a lot of our gaming companies are huge users of big data. They're embracing MongoDB. They're using Hadoop. They're using React. They're using Cassandra. And they're doing a lot of data crunching. And Clash of Clans just happens to be one of my favorite games, and I'm a sucker for it. And I can see that in action with that game almost every day of how they're leveraging that data to drive user engagement. And then the financial industry. A lot of the financial industry is still in-house. They have incredible demands on latency and on throughput. They push. When you have conversations as a cloud provider, a lot of it comes down to the performance of the network, performance of the overall infrastructure. But a lot of the financial institutions are still in-house, and it's because of the performance demands that they have, where 10 milliseconds, 50 milliseconds is a huge difference to them, and they're willing to pay for that. And they're really pushing the network vendors in that space. And then the science industry, Large Hadron Collider. If you look at that, when they collect the data off of events off the Large Hadron Collider, it can generate as much as 300 gigabytes a second of raw data. And they distill that down into something in the neighborhood of 300 megabytes of meaningful data. And then it generates now in excess of 25 petabytes a year. And so when those events happen, the latency demands of being able to capture that much data that fast is really demanding on the infrastructure. And I think that's why you see a lot of the science and research still really driving their own infrastructures and helping feed that back into cloud. So kind of setting that up as a lot of the key use cases that we're seeing right now, we talk about it from a cloud perspective. And so we go back to that kind of that web use case. And we talk about cloud. Obviously, not all clouds are created equal. And cloud is not just cloud in terms of I go to get compute. There's a lot of aspects to cloud. So when we look at public cloud, we think about virtualized public cloud. It's a great use case for web. It's a great use case for app tier. And typical public clouds, 1 gig Ethernet interfaces. And is the 1 gig interface. The public cloud provides more than enough latency for those applications. And so what we find is that most use cases are, those applications are powered by a public cloud. And when you talk about throughput to disk, whether it's local disk or you're talking about SAN-based disk, a lot of those are SATA. So traditional spinning disk, 7,200 RPM, more than meets the needs for this use case. We'll go to the gaming use case. What we see on this is because these clients are making so many connections back to servers, they need to have scale-out architecture. And so the mobile applications are taking advantage of virtualized public clouds to scale out. They can scale out rapidly, they can scale down rapidly. But they're also starting to take advantage of bare metal servers. And from a SoftLayer perspective, it's one of the things that we've been focused on since our inception, but really is delivering the equivalent of a dedicated server that companies may have in-house, delivering that in a cloud model so that you can have true hybrid compute that is virtualized public cloud and bare metal cloud. Bare metal cloud just means there's no hypervisor on the server, and you get every ounce of performance as well as a degree of customization of that server. And so companies like gaming companies take advantage of that by having their web tier, their app tier in a virtualized public cloud, and then they put their demanding big data applications on bare metal servers. So they get the data, and typically they run those with 10 gig network interfaces. They can put a lot of data through that, and then also it really decreases the latency. So we see hybrid architectures, advanced hybrid architectures now in place with the gaming industry, with social media applications. And then from a financial perspective, we are starting to see financial institutions move to the cloud and start talking about the cloud. Obviously, a lot of the core assets that they have are going to stay in-house. And in a private cloud. That could be an on-prem private cloud, or we're starting to see that transition to the public clouds. But it's really about control. It's about being able to really define the characteristics of that private cloud and have really fine-grained control over that so they can get the ultimate performance to meet the demanding infrastructure needs that they have for their industry. And then they start to move into something like InfiniBand, where you start talking about 20, 40, 80 gigabytes or 80 gigabits a second as compared to 10 gig. And it gives you a layer of virtualization. So from a performance standpoint, this kind of sector of the industry really is kind of pushing the boundaries of leveraging cloud technologies to their advantage. And then we look at the scientific industry. A lot of times it's custom. This is where a lot of the technology starts. They're pulling together arrays of computers. They're leveraging RDMA, which is a remote direct memory access. So they end up having these large, effectively supercomputers with shared everything. And it allows them to not only gather the data quickly, but to analyze that data, crunch that data, and then get the results back. So we look at kind of where we are today from a cloud perspective. Really, 3/4 of this is covered today by cloud providers. And as enterprises make that move to the cloud, whether they're starting from scratch or they're starting to make those transitions from the enterprise to the cloud, I think the most important thing that we've seen is really not only understanding your application, but understanding how to best deploy that onto the cloud. And again, I said it earlier, but one size does not fit all. So it's not just about going and getting a certain compute size and pushing your applications up and scaling it. Now, in a lot of cases, that may work. But it's really understanding the cloud infrastructure, understanding what the demands and needs are of your applications, how to scale it properly, and then ultimately what that performance needs to look like. So from a SoftLayer perspective, that's our focus today. Really making sure that we have complete coverage. And then I mentioned IBM. The beauty of working with IBM now is that we have access to a lot of their research to help us extend the cloud into the future. And then just some exciting times around what's happening in the cloud. Open source, OpenStack, some of the new stuff with Docker. A lot of this is going to help shape and grow and mature the cloud industry even more. Then we look at kind of what's next, and Alistair actually mentioned this, but and I'm not just saying this because IBM acquired us, but I think one of the most exciting things for me is our projects like Watson, where you see kind of research that started in a lab, really pushing the boundaries of technology, and now we're starting to see the benefits of that, and it's not just say from a cloud perspective, but actual implementation and use of that. And so it's leveraging a lot of the key tenets of what has become cloud. But ultimately, we're going to see this kind of extend into the future evolutions of cloud. So right now, with our customer base and our prospective customers, we're really saying that the cloud is for real, and it's not just simple anymore. It's really can be advanced, it can be complex, and we're ready to really build the future with our customers. Thank you.